everyone. Good morning, good afternoon, and good evening to all who are joining us today. A special welcome to all of our veteran attendees as you have come into our fourth water cooler chat here. And excited to also see several new folks joining us today. I'm Meena Sankaran, founder and CEO of KETOS, and I'm thrilled to host this session today. As all of you have joined KETOS in this journey of collaboration, inquisition, and learning various aspects of digital transformation in water, I'm thrilled that we will be able to dive a bit deeper today with a very special guest. We've touched upon topics of water quality monitoring by KETOS and what are the latest trends in the past. But today, by populist demand, we want to dig into the why, where, and how these use cases associated with water quality monitoring can benefit you. Key word of the day, process controls. And your takeaway for the day is going to be how can data-driven insights in your process control help transform your operations? So joining me today is our esteemed guest, Kevin Fisher, who I've had the privilege of meeting almost 2.5 years ago. He is one of the most foresighted thinkers in the water industry with over 30 plus years of experience. And having been a former utility director himself, understands all the nuances, the pain points and solutions in the world of water. Having gotten to know him, he's also a wonderful human if you ever get to know him. And he has been a voice of reason for a lot of technology companies as one of the most supportive advisors driving change in this sector. We are very grateful for his time today. And with that, Kevin, welcome to the KETOS Water Cooler Chat today. Welcome. So diving in, what I'm gonna do is, there's a lot of things that I would love for Kevin to share with you guys today. So one of the aspects as I transition over and hand over to Kevin is for all of you to start thinking at the state of water quality monitoring, the state of water safety in this country, and really why people only think of compliance when they think of digital transformation and monitoring. So I'm going to hand that over with you, Kevin. So take it away.
Good morning. I can't say enough about Meena inviting me here. I'm thrilled to be here, of course. I'm the current Chief Technology Officer for WaterStart. I just got to throw them out a shout out. WaterStart essentially provides a channel for accelerating new technologies for their membership. The membership is typically heavy water users, mining, water agencies, hotel chains, and we have footprints in Australia, California, Nevada, England, Arizona, and we search for new technologies for really aggressive, innovative-minded agencies. So I'm thrilled to be here, and I wouldn't be here without WaterStart. So if you need to know more information about WaterStart, just go to waterstart.com and do some exploration. When Meena brought up this discussion, I was thinking about data and how instrumentation works in the water agency and how we're using it. I had to back up a little bit and say, well, where are we now? So this is kind of an old statement. It came back out in 2017, but as water agencies and wastewater agencies, we essentially got a D for how we're maintaining infrastructure. And one of the answers was, despite these trends of the water agency and our infrastructure is dropping off, we could use sensors to help us better operate our infrastructure. And I'm not talking about compliance sensors, ones that would say how much chlorine you have in the system and things like that. I'm talking about processes that are out there and be able to keep your hands on the processes before things go wrong. And we're going to talk about 3 or 4 examples of where this concept of not using compliance type data, but using data to help you stay compliant, if that makes any sense. So we'll go through that. And the problem, and I'm looking at all these sensors out there, how do you do that? What do you do with all this data that's coming in now? We've all seen now AMI systems coming in, Meena, if you would advance to the next slide. Thank you.
Yep.
We've seen all kinds of new data come in, all these new instruments. If you look on the left, there's AMI systems, all kinds of metering systems, there's water levels. I mean, I could go on. Energy consumption, pump efficiencies, we've all seen these. Pressures, temperatures, there's TTHM monitoring. I'm just mentioning a few as I go down the list, but that is a massive amount of data. Some of it is for compliance, of course, and just how to operate the system. We've been doing that for years. You look at tanks, their levels, you look at energy, how do I select pumps? Well, the same thing can be done with water quality. We can use a lot of this data and instrumentation to help us better operate our system. And it opens up just a myriad of opportunities. There's energy opportunities, like are we wasting energy in this process? That's not necessarily a compliance goal, but it's for our customers. How do we lower their costs? Water quality opportunities. You know, if I had operated the system, if I had known that this was happening out in the distribution system, I could have given my customer better water quality. So I'm really excited about that. You know, you can improve water quality without the hammer of compliance over your head. You're just doing it because it's a better job. Data comes in on asset management. There's opportunities out there on how to better take care of our pipelines, how to better take care of our pumping infrastructure, our storage infrastructure, our wastewater structure, all this data coming in. And then some things that people don't realize is human resource opportunities. If you have these instruments out there in the field, and of course they do have to be maintained and they have to be watched, but it can save a lot of energy and just instead of sending somebody out there to do the typical grab sample, you know, and they come back in and they run it through the laboratory, and then a few days later, the result gets back to operations. You could have somebody in operations going, oh, I see that's happened. They didn't have to send the person out there to get the sample. They can send the person out there to fix the problem or make the appropriate adjustment. So using this instrumentation to better operate our systems, not necessarily just for compliance, but just to make us better at what we do is just huge. Okay, let's go to the next slide.
And that's very insightful, Kevin. And when you're thinking about like the different aspects and different use cases within digitization, within looking at non-compliance versus compliance use case, and operators now have to shift that of really thinking about how they've traditionally looked at data to now. What are some of the sort of useful aspects as they look at these non-compliance use cases or rules and regulations within their utility, within their industry, for them to even have that conversation with their peers and remove those hesitations?
Well, so there's a little bit of a mindset about, I do these things, and the water industry is very risk aversive for good reason.
Right.
You know, they don't want to get people ill. They don't want to do something wrong and hurt any individual. They want to make sure that the water they serve is safe and potable. I mean, that is the prime directive of the operators. Getting them to think about using different tools and to trust them can sometimes be a huge challenge. That's kind of one of the things that gets in the way of, boy, I've always done it this way. I'm very conservative. This is the way my dad taught me. This is the way I'm going to teach my son, right? It carries through the generations. With innovation and looking at instrumentation, sometimes there's a bit of a jump to gain confidence in the new systems, both through management and in the operators. So we'll talk a little bit about that and give you a couple of examples, Meena, that I think would help make people feel possibly a little more comfortable in trusting instrumentation to do that for them.
Awesome.
So on this slide, the poor people in the water industry, they are hammered with rules. There's a rule for rules. I mean, it's just amazing. They have to deal. I started out with a couple of simple ones, like the arsenic rule and the consumer confidence reports that we have to put out. Backwashing filters, there's rules for that. The groundwater treatment rule, interim enhanced surface water rule, the lead and copper rule. I mean, it just goes on and on and on. The stage 2 rule, standardized monitoring you have to have. There's a total call for it. It goes on and on. And these are pages and pages of rules that are not simple. So there's a lot of things going on in the operation. It's just not like turning on a pump, of course, and all the guys and gals in the water system know that, and they're saying you're preaching to the choir. I just want to make a point that we recognize that compliance is absolutely important. But how can we better do compliance? I think the best way to do it is to catch a problem before it occurs. So we can use instrumentation in our processes to say, hey, this doesn't look right. I see, this trend is bad. We need to do something about it. So we're going to explore some examples here in a little while. So make sure that everybody meets these rules. So let's go to the next slide, if you would, Meena. So the importance of quality. With the complexity of these rules and the importance of serving only safe potable water, again, it's unbelievably extremely necessary to identify these issues before they impact our community that we serve. And I can't hammer that enough. Why wait until we see a problem at the plant for a grab sample to come in that could be a couple of days old going, we have a problem that's already now been in the works for 2 days, when we could have seen it online immediately and already made some fine-tuning adjustments. And I'm going to repeat that term again about fine-tuning. Here's an example. So this is an acute example. Acute meaning once you blow the rule, you've blown it. Now the exception here, of course, is chromium. But let me go on to the next one. Bear with me for a second. So that what you're looking at there is an arsenic contactor. They typically put 2 or 3 of these canisters in a row, and the water goes into the first canister, or if you have only 2 canisters, it goes into the first canister, the chlorine gets absorbed, or the arsenic gets absorbed, treated, and the water comes out and it's sent to the customer. Well, they have to send somebody out to these rural sites, or these sites are typically, it's a very small tank. You can see it's at a rural location, and they can get breakthrough. So arsenic has already loaded up this tank, and they have to be aware of when to switch to the next canister. Well, now instead of sending somebody out to get a compliance sample, they can watch this canister, the discharge on this canister, and when they start getting breakthrough, they can say, okay, it's time to switch over to the next canister without sending people 50 miles out in the middle of nowhere and back to get these samples. They can watch it from afar. So there's a human resource savings there. And in this example, the rule is 10 parts per billion, at least. Now, some states may have it lower, but the EPA limit is 10 parts per billion. And the example here, the instrumentation can go as low as 2.5 parts per billion. So they can see it starting to do breakthrough. They go out there, change the canister. The same type of treatment can be for nitrates. Now, nitrates, once you go over the limit, you've blown it. It's a reportable. And all water companies know that it's not the fine that makes us compliant. Like EPA is going to hit you with a fine. That's not true. Here, it's our good name. We want people to trust that we are serving safe, potable water to our community. So the best way to do that, never have an administrative violation or any type of violation. So here, nitrates, you can monitor for nitrates as low as 0.5 parts per million. And you'll never have a dose given to the community that meets this limit. Now, this is important because now with reclaimed water, recycled water, they're putting fertilized water on golf courses, there's septic tanks out there, and they are slowly contaminating the aquifers. And a lot of customers have seen nitrate levels in wells climbing up. Some of them climb up rapidly because they're not sure where they come from, or a septic tank could have a problem where there could be something change in the aquifer. So you could have a violation even though the trend was below. If you averaged all your samples, it would be lower. It could be better than that. So my point here is don't blow an acute. You don't have to blow an acute level. You can just stay well below it, monitor it continuously. If you see a problem, you can shut the well off before somebody brings a sample in and says, here's the compliance sample, and we've already blown it. So there you go.
Got it.
Chromium is the same way. Meena, did you have a comment?
No, I was curious about, as you're seeing arsenic, nitrates, and chromium out there, I mean, how many times is someone going out there to grab a sample, and how many times are we, are the operators, missing it? Like it's not something that you can predict, at least not with your traditional approach of how we monitor, right?
Right. And it becomes more critical as the levels climb up in these wells, you get closer to the 10 parts per million range. So are you going to shut down a $1 million well because you can't monitor the nitrates?
Yeah.
Well, you wouldn't want to. You could set an alarm and saying, if this thing approaches 9 parts per million, then I'll shut it down. And it could actually be, almost automated through the SCADA system. That's not a compliance sample, but it's an operational decision sample that's incredibly valuable. Chromium, chromium is it's a unregulated contaminant right now, but it's under monitoring. So they're going to set that, I believe right now it's set at 100 parts per billion. And some wells, as chromium is in the environment and it comes up, it can creep up on you. This is just another one if you're doing chromium treatment for chromium-6. The same thing between the canisters on all 3 of these. You can set this device up and you can watch for chromium. And if it starts to get too high, then shut the system down or transfer it to the next canister. Okay, let's go to the next example. So that was an acute example. Now here's one that I always thought was interesting. I've worked with some systems that had, for example, there's a system in Nevada that they use salt on the roads. And the salt makes its way down into the aquifer in a very finite way. And just enough salt was able to convert the Langmuir index on the water to be aggressive. So they started to get lead copper contamination, very low doses. The utility was very smart and they wanted to start putting in with the state. They worked with the state, did some tests, and they found out that orthophosphates will keep this corrosion down. But if you're familiar with lead copper sampling, in Nevada at least, and in most states, they are responsible for the water through the tap as far as corrosion goes. So the samples have to come from the customers. And they average these samples over time. And they watch the zinc orthophosphate as it's going through the system to make sure that they are not getting corrosion on the lead copper rule. So it's an average of things, but you don't want anybody getting lead copper doses anyway. You don't want them to have a spike in there. So what if the zinc orthophosphate shuts down, or for some reason it's not making it to the extremities of the distribution system that are experiencing this type of corrosion, the older homes that have lead piping, things like that. So you can use this instrumentation not as the compliance sample for lead copper, you're using it for the orthophosphate to make sure that it's getting to the customer's residence and preventing lead corrosion and copper corrosion. So they're doing something above and beyond for the community. And you can use trends for orthophosphates. I ran this through a couple of chemical engineers and they're like, we never thought about that, but hey, here we are. So there's an opportunity there, thinking a little bit outside the box. So I thought that was kind of an interesting one because I've seen this whole process happen.
And for all folks, just a reminder, please feel free to start, popping in your questions at the chat window, because I do encourage you to get some questions at least answered live, while other questions will, close off with Kevin and I through a blog or a also, there's a poll launch, so please do let us know what sector of the different parts of the industry you're coming from. It's very helpful for us to understand, and also cater to some of your questions as you're coming through in follow-up sessions to meet your needs. So, we heard about our arsenic, we heard about chromium and nitrates, and specifically orthophosphates. So I'm going to keep going here. We talked a little bit about drinking water. Now we're thinking about wastewater, because I think we have a good blend of people between water and wastewater. Curious about how all of this translates to the wastewater world.
Yeah, wastewater, I am not a wastewater expert, so I called up one of my buddies at the wastewater facility here in the area, and I said, let's just explore. Again, he had no idea. So let's explore how we could use a sensor just to make sure that the lake water where it was dumping to, that the phosphates were removed. And I was fascinated. He got excited about it. I just saw him just kind of open up, and we came down with, we could use an instrument to look at the phosphates that are dropping down into the lake. And the plant has a goal of reducing phosphates. Of course, they have some goals. And I said, how are you tracking that? You just go out there and get a sample every so often? He goes, well, we can fine tune the plant every so often with grab samples. And the idea was, what if we had an instrument to do that? He's like, oh my God, where have I been? Because as these things are being developed, they didn't always have a phosphate analytical tool sitting on the discharge side of the plant. Those weren't always available. So it's just a matter of catching up with technology. And through innovation and opening your mind to it, being open to it, it could solve a problem for them. And he's actually going to explore this in fine tuning his plant. So I thought that was kind of interesting. There are wastewater plants are far more, don't yell at me, any of you treatment guys, but wastewater plants are far more complicated than a water treatment plant. I could think of some examples on a water treatment plant for tracking, bromates, tracking chlorine residual. There's all kinds of stuff you can track to make sure that the plant is running smoothly, not just to meet the rules, but actually smoothly. So I was really excited about that, to see that the wastewater group are doing the same thing. Let's jump one more slide. So here's a device that I've had some experience with. We used it in the example you saw previously for arsenic monitoring. It was not used for compliance, but it was there to make sure that compliance was achieved. And there is a bold difference there. And it was done through a group that very innovative water agency. They're not afraid to take a step. And I've used innovation, that term, a few times. And I just want to mention it a little bit. We're so risk averse in the water industry that we're almost afraid to try new ideas. Even our purchasing rules prevent us from exploring new ideas. Like, here's a new instrument, how am I even going to pay for it? So I'm going to give Meena an opportunity to talk a little bit about the KETOS shield fabric and its capability. But in the end, one more slide, if you would there, Meena, for me. I just can't say enough. Don't be afraid of innovation. I mean, in all honesty, I don't see how you can afford to ignore it. People have asked me before, well, how can you do innovation in the water industry? And I look back and I'm saying, how can you not? So with that, I'm going to hand this over to Meena and have her talk a little bit about the KETOS shield.
Oh, thank you, Kevin. Well, first off, everyone, I think, really a lot of insightful conversations, a lot of insightful use cases, Kevin. Really appreciate you sharing that. And I think that's just the tip of the iceberg here under our limited window. I think if we really have to dive into just a variety of use case, whether it's asset management or water quality monitoring, I think Kevin can probably unlock a lot more for you. So I definitely encourage you guys to reach out and speak with Kevin offline as well, or anyone from KETOS and myself. Happy to answer any other questions you might have. So, just before we wrap up here in a few minutes, a little bit more about KETOS Shield, what Kevin was just referring to in several of these use cases. One of the biggest differentiators for, what KETOS Shield brings to the table is the ability to autonomously monitor not just your physical parameters like your pH, conductivity, TDS, salinity, DO, temperature that you're typically used to with a handheld probe or a combo probe, but really moving into sort of the variation of heavy metals, of understanding arsenic, nitrates, chromium, nutrients like nitrates, and sort of orthophosphates. A lot of, we've also encountered manganese in terms of a lot of groundwater monitoring concerns, lead, copper, cadmium in certain cases, especially now getting a lot into industrial. You'll hear about requirements on the selenium front, iron, mercury, zinc. So as you're thinking about whether is it possible to have an instrumentation that allows us to understand data at a part per billion level, far below sensitivity that an EPA even permits, it's possible. The technology is there, the solution is there. The question is, are you ready for it? Does it make sense within your environment, and how you're able to integrate that? Our goal has always been about interoperability. So we don't expect, to always enter a greenfield environment. The system is something that's very flexible and easily integratable within your existing SCADA system, or whether you want our platform to become that de facto platform for you in integrating a lot of the third-party data. Because at the end of the day, it's about what's the right solution for you in your environment with your existing operators and all of the resources you have to move the needle forward. It's not a one-size-fits solution for everybody, and we're here to make that possible for you. Another one thing I would leave you in terms of takeaway is remember that, you know, your traditional model of budgeting, the way Kevin was talking about, is also something we're truly trying to walk away from and help customers realize that technology is constantly evolving. You're going to see the next new thing within the next couple of years. And so for us, the most important thing we can offer a customer and operator is that ability of adapting to the age of digital transformation. So our solution is completely 100% a subscription-based model. You're not worried about maintenance. You're not worried about consumables. You're not worried about calibration and cleaning because our system is able to self-calibrate and self-clean. And most importantly, you have a $0 CapEx model. And so it's not just the technology innovation, it's also the business innovation of helping operators adopt and integrate it into their environment while policy changes are being made. So I think we have to look at it from a very holistic standpoint. And I'm really glad that, you know, KETOS is part of that solution and being able to help you on that journey. So with that, there's several questions coming in, Kevin, but one question I have for you is, you know, as people are stepping away today, taking some of the use case of, oh, can I use it in my groundwater monitoring? Can I use it in surface water? Or can I use it at the discharge? What are, you know, 3 things you want folks to walk away in terms of how to think of real-time intelligence for their own operations and how to, you know, sort of get past that risk averseness in terms of just being able to adopt something in their environment?
Thank you. When I look at risk aversion, it's part of the culture. This ties into one other question we received about recommendations or strategies to help water providers get funding for additional sensors. It's an overall attitude in the agency about serving the customer. I believe myself that innovation has to be in the culture where people are not, they're somewhat rewarded for looking outside the box. Instead of the punishment for making an error when something doesn't work, it should be a reward for trying something new in a controlled environment. So one of them for like, how do you even pay for this stuff? Well, I was fortunate enough to work with an agency that finally they had an innovation fund. They recognized what it was for and went to their board. And they said, this money is to help us do a better job. It wasn't selected for a type of infrastructure or a type of pump or instrument. It was for the fact that innovation is important. So they were able to reach into that pool of money with a committee and say, we would like to try this instrument, knowing that it's based on one of our foundations of our culture, which is innovation, which is going to be used to help us to keep pace with our customers' demand and their needs. So it was kind of recognized throughout the agency that it's okay to make this purchase. The board has said it. That's what the money was set aside for, so they could buy that instrument. And when they see that, operations engineers jump on board, and they're willing to say, okay, let's try this in a controlled environment. So that's one of the strategies I would recommend for them to get some instrument to get rolling.
And one last question before we leave off here, Kevin, is as you're thinking about data coming in, how are you thinking about data and integration as a operator, and anything top of mind from a security standpoint? And it's a big one for a last minute, but
no kidding.
Like we can still squeeze in one answer.
Well, I think it's probably a couple of PhDs written in there, but I think the idea is for security and things like that. You know, I never thought I would see the water agencies allowed to use the cloud. You know, I remember the first time we said, we'll never use the cloud. Well, now they're all using the cloud. And so as far as security goes, the instrumentation can be used for security, water quality monitoring on your intakes. You can things that you're concerned about. As far as security in the cloud and using that's gone to the side. We know that we can secure the data. And as far as joining it with other data, there was a question here about how do you know that there's false alarms and maintenance and calibration. Well, false alarms are on any instrument. You can have a false alarm on a level indicator. You can have a false alarm on a chlorine residual. So the idea is through experience, you learn how the system works, you get comfortable with it, and then you use it like your car. You drive water quality home for life. I don't know another way to put it.
Yeah, and another comment I would make is it depends on the type of instrumentation for the maintenance piece of it, because with KETOS Shield, we actually do a quarterly maintenance, and the system has the robotics built in for the automation that desires for all the calibration needs that typically people are struggling with in terms of labor intensive processes, and also all of the concerns on false alarms. Happy to address that even more in detail offline if someone is interested on how we address false alarms or that, because that's such a common issue. So with that, I know we've gone a little over, but really appreciate everyone's time here on a Tuesday. I believe it's a Tuesday. We lose track of days. But thank you so much, everyone. Pleasure having you on here, Kevin. Thanks so much for your time. Really appreciate it. Have a great rest of the day, everyone. Look forward to seeing you on our next water cooler chat. Take care.